and welcome to my YouTube channel. I'm Arthur Francis Deba. So we are continuing from where we stopped in organic chemistry. So we've dealt with alkanes and the reactions therein. We've also dealt with alkenes with its reactions, but now we are on alkynes. We're going to begin with alkynes, and we have to work across board. So certain reactions they undergo, and we're going to also have to name some structures that are associated with alkynes. And we are intrinsically going to deal with some other structures that have to do with double and triple bond. How do we name them? Then after which we may likely go to our functional groups, which is going to be our last aspect in the naming of organic compounds. The functional groups in the compound consisting of two or more functional groups. Which one should come first? Which one take precedence over the other? All that we're going to deal with. We're going to take them stepwise. So like I said, alkynes. They are a third member in the hydrocarbon series. We divided it into saturated hydrocarbons, they are unsaturated. So alkynes are the unsaturated, the triple bonds. And we have alkenes which are also unsaturated, but they are double bonds. So let's deal with the general molecular formula and see how we go about that. Okay, we have in the alkynes, we have the general molecular formula to be CnH2n minus 2. In the alkenes, it was CnH2n. In the alkanes, it was CnH2n plus 2. So this one is now minus 2. So from here, we're going to deal with our first members. So in the alkynes, we have here we don't have methane. We have ethane. We have the propane, and so on. So let's take ethane, which is 2. So if I have C2 here, H2 times 2 minus 2. So this will give me C2, H4 minus 2 is 2. So the structure now becomes 1, 1, 2, 3, 1. Hydrogen here, there are 2 hydrogens, so this is 1 and this is 1. So this is our first member, the ethane. And let's see, we say carbon is tetravalent. Let's check that. This is carbon. We have 1, 2, 3, 4. So this is complete. Carbon, 1, 2, 3, 4 is tetravalent. So if we take another member, let's say the butane. Butane means 4. So I have C4, H2 times 4 minus 2. C4, H8 minus 2 gives me 6. So let's see how the structure, or what the structure is going to be. So I have my 1, 2, 3, 4. The triple bond can be anywhere, but let's take it to be in the terminal carbon. So we put our hydrogen. This is one of them. 1, 2, 3, 4. This is complete. 1, 1, 1, 2, 3. So we count our hydrogen. 1, 2, 3, 4, 5, 6. So the hydrogen are 6. The carbon are 4. 1, 2, 3, 4. This gives us our butane. In this case, it's just called butane because the triple bond is in its terminal carbon. So I don't need to call it one butane. We understand why it has to be like that. But if it is in the middle here, that becomes 2 butane, where we're going to deal with isomerism, where we have different structures that can be coined out from one compound. So now, this is it. I have that. So if I take pentane, for example, another example, pentane is 5. We have C5, H2 times 5 minus 2. C5, H10 minus 2 is 8. The structure now becomes 1, 2, 3, 4, 5. Let's call the triple bond to be in the terminal carbon as usual. The hydrogen, I have 1, 2, 3, 4, 5, 6, 7, and 8. Now, this is also 3 here. 1, 2, 3, 4. So this carbon is complete. It doesn't need any hydrogen. It is already tetravalent. This other one is 1, 2, 3, 4 for this. And so all of them are. So this thing goes a long way to understand the principles of application of your hydrogen in the carbon bonds. Some of us may make the mistake of putting maybe hydrogen here. Well, once you do that, it becomes pentavalent. It's more than 4, and that would not be correct. So let us go further to the rules of naming the arcanes. Just like we had the rules in naming arcanes, they are very similar to those of what arcane, except that there are just few differences. So let me go through the rules so that we will see the difference therein. We say the name of hydrocarbons with carbon-carbon triple bonds are obtained by replacing the ending "ane" in the corresponding alkanes with "ine." You don't need to write, just listen. The general procedure for naming alkynes is the same as in naming alkenes. Since we have dealt with alkenes, so you will know the difference isn't much. When the procedure is applied, then the various structures which I'll give to you, you see that the principle still goes along the same way. Let us take, for example, this structure and name this. Okay. 1, 2, 3, 4. Before I take the structure, listen to the principle. They say, when both the double and triple bond are present in one structure, we have both double and triple bond. When they are present in a molecule, assign the lowest possible number to the first carbon containing the multiple bond in the parent chain. So the first of it that contains the double bond should be given precedence to be senior over the other one. You will see how that goes. Then we name the "ine" first, then before we name the "ine," the triple bond, the double bond before the triple bond. Let's take, for instance, this example here. Listen to the rule. For instance, they say, for instance, in this particular one, we should give the lowest, they say, when the both double and triple bond are present in the molecule, assign the lowest possible number to the first carbon containing the multiple bond. So that's what we're going to deal with. So let's see, how is that? Okay, from here, if you check from this first carbon, I want to assign them. Here is 1, the triple bond is in 1. Here, the double bond is in 1, 2, the first case here. So in this instance, all of them appear to be 1, 1. But now, why should we give preference to this side or this side? We now check what the substituent. The substituent here is in carbon 2. If I come from here, 1, 2. If I come from here, 1, 2, 3, it's in carbon 3. So this side, the locant here is 2, while here the locant is 3. Therefore, I start my naming from here. So since I'm starting my naming from here, I must give precedence to this, being senior over this. Am I understood? So therefore, I have my 1, 2, 3, and 4. So having said so, now this substituent here, the name of the substituent is what? Ethyl. Remember in our rules, they say we should look for the lowest chain that contain the double or triple bond. If I come from 1, 2, 3, 4, 1, 2, 3, 4, they both are 4, 4. But I'm giving precedence to this side because it contains the double and the triple bond. So this is where I go, not here. So if I go this way, this becomes what? My substituent. So I have ethyl in 2. So I say this is 2 ethyl. Since I'm giving precedence to this, I'll come here. This is the chain is what? 4, which is supposed to be butane or whatever it is. So I call it 2-ethyl but. This is 3 first. 3-ine. 2-ene. 3-ine. Now this is supposed to be, if it is just this, becomes 2-ethyl 2-butene or butane, as the case may be. But I have more than one double bond. So this becomes 2-ethyl but 3-ine 2. Oh, sorry, it's 1. 1-ene, not 2. Now, but 3-ine 1 in. Because the triple bond is in 3 and the double bond is in 1. So they becomes 3 in, 1 in. By so doing, I have this. So if you want to name it the other way, so this becomes 2-ethyl, 3 in, 1 in. If you want to put butene or butyne, it becomes confusing. So that is why we must start with the boot. The other way around, unlike the reverse. So let's take another structure so that we can see what we do with it. I have another one here. Okay. So we start our look at the lowest possible number. So if I come from here, 1, 2, the double bond here is in 2, but the triple bond here is in 1. So this takes precedence. The lowest possible number in local. You must remember that. So if this takes precedence, so now I have to consider this. This is my substituent. 1, 2. So I can come from here. I have 1, 2, 3, 4, and 5. 1, 2, 3, chloro. Alright? 1, 2, 3, 4, 5. Let me write it. 3 chloro. Okay, yeah. 3 in. No, pent. We're in pentene. 3 chloro. Pent, because it's 5. Remember, 1, 2, 3, 4, 5. So it's pent. Pent. What is this? It's in 3. 3 in, which is double bond. 1 and triple bond. The triple bond is in carbon 1. The double bond is in carbon 3. So you must take that. 3 chloropent, 3 in, double bond, 1 ion, triple bond. So by so doing, we move on. Let's take another one. Here again we go. The parent chain is 1, 2, 3, 4. 4, and we have a triple bond. So 4 naturally is butane. Okay? 4 give us butane. So now we have a substituent. Because the triple bond is closer to this side, this becomes my 1. So here I have 1, 2, 3, 4. So 1, 2, 3. 3 methyl, there is a substituent in carbon 3. 3 methyl but 1 ion or 3 methyl butane. Any of the two will suffice. So I have 3 methyl but 1 ion or 3 methyl butane. It is butane because the triple bond is in the terminal carbon. I don't need to specify. If I call butane any day, you know too well that the triple bond is in carbon 1. So in order not to bring it in, you can call it 3 methyl butane or 3 methyl but 1 ion. Let's look at isomerism. Like I said earlier on, I said isomerism is a phenomenon whereby compounds having the same molecular formula, but they have different structural arrangement. So if that is true, isomerism existed in alkanes. It also existed in alkenes. Let us see it in alkynes and see how we can deal with that. So in the course of us talking of isomerism in the alkenes, we also talked about the types of isomerism, positional and structural isomerism. So let's call them generally, we'll put them here. So now in isomerism, which I say again is a process or a phenomenon where compounds having the same molecular formula but different structural arrangement. Let's take this one. 1, 2, 3, 4, 5. Triple bond. You know that there are hydrogens everywhere here. So this is what you get. That is what 1, 2, 3, 4, 5 is pentane. I don't need to tell you it's 1 pentyne because the triple bond is in carbon 1. Let us see how many isomers can exist here. How many can we get out of here? So the next one here, I will have 1, 2, 3, 4, 5. If I put the triple bond here, this becomes 2 pentyne. It is an isomer from here. So let me call it 2 pentyne. I can get another one. 1, 2, 3, 4. I put my triple bond here and I put a methyl here. So this is H3, 1, 2, 3. This is 4, 1, 2, 3, 4. 4. So this is 1, 2, 3. 3 methyl, 1, 2, butane. Okay, 1, 2, 3. In 3 we have a methyl. So 3 methyl butane or 3 methyl but 1 ion. So I don't need to tell you it's but 1 because it is in its terminal word carbon. Alright? So by so doing, these are all isomers. I am able to coin this 1, 2, 3 structures from 1, 2, 3, 4, 5, C5, H, 1, 2, 3, 4, 5, 6, 7, 8, H8. So this is a molecular formula. Okay? In this molecular formula, I have been able to get 3 structures. That is why we say isomerism is a phenomenon whereby compounds having the same molecular formula but different structural arrangement. You can see their structures are different, but all of them were gotten from what? One molecular formula. So that is what we call isomerism. I don't need to overemphasize or stress on it. Let us move further to see reactions that take place with what? The alkyne what? Family. In the alkenes, we talk of certain reactions, which is additional reaction, where we have hydrogenation, the reaction of the alkenes with hydrogen. We have halogenations, reaction with halogens, hydrohalogenations, reactions with hydrogen and halogens, and so on. That same reaction take place in what? Alkyne, because of the triple bond. That reaction was possible, in short, is possible in all unsaturated hydrocarbons, which are the double and the triple bonds. Let's see how we can apply that here in what? The triple bond with our halogenations. And in short, the additional reaction generally. So the first one we call, let's call it hydrogenation. Reaction, the additional reaction, okay, first. Now, hydrogenation is a reaction that takes place with the hydrogen replacing the double bonds. So, let's take the simplest member, which is 1, 2, 3 days. This is what we have. Plus hydrogen molecule. What do we get? Now, remember, I told us that in the course of the reaction, I've shown you the mechanism when I was dealing with the alkene. So I don't need to repeat the mechanism here. But what happened is this hydrogen will remove one bond here and replace hydrogen in these 2 carbon atoms. So here I will now have carbon 1, 2. It is now double bond. And there will be another hydrogen here and another hydrogen here. This hydrogen will break one bond and replace it with 2 hydrogen here. And this is what happened. So this becomes what? Ethene. So simply put, we will say ethane undergoes additional reaction to give us what? Ethene. Okay? And we know that ethene can still undergo additional reaction to give us what? Ethane. If I decide to put my plus H2 here, that will definitely give me, if I come down here, to give me C double bond. Hydrogen, hydrogen, hydrogen here. This becomes ethane. So, complete hydrogenation reaction of ethane will give you what? Ethane. Complete, which means it has to undergo over and over. Alright? Will give you what? Ethane. Now, if it is not complemented with just hydrogen molecule, it will give you ethene. A question can be asked. Like you always see that in West African Examination Council questions, like A complete additional reaction of a time gives you what? It gives you a thing. Complete, which means it has to undergo the first stage and the second stage. When it gives you a thing, it reacts again to give you a thing. But if I ask you the additional reaction of a time will give you what? A thing. That is it. The additional reaction of this will give you this. If I say complete, means it has to undergo again to give you this. So let's see what happened again with another example. Okay, this is it. 2-butane reacting with, let's call it chlorination now. Chlorination. Reacting with chlorine, Cl2. What do you get when you do that? Now it's reacting with Cl2, which means this Cl2 is able to break one bond here to give us a double bond. So let's see what we get. We have 1, 2, 3, 4. One bond will be gone, and the chlorine will replace these two. So I have Cl, Cl. Okay, so now I have hydrogen here to balance that. Here, 1, 2, 3, 4 is complete. 1, 2, 3, 4 is complete. So now this becomes what? 1, 2. In carbon 2, I have my double bond. So 2, 3 dichloro. Let me write it. 2, 3 dichloro both with 2 in. It's now in. Or 2, 3 dichlorobutene. Any of the two you want. So that is what happened in the additional reaction. Additional reaction of what? This. We can do it with chlorination. But remember I told you the basics. The basic principle for this is the mechanism. What really happened? We have shown it before. So just go back to the alkanes video and watch it out to see what really happened. Let's take another additional reaction with hydrohalogenation. Let's take example. We still have our ethyne. This is our ethyne plus hydrogen chloride, HCl. What do we get? Now remember this bond will be gone. These two will replace them. So I have my base 1, 2. This. This will come over here. I have one hydrogen here and I have chlorine here. So if this is true, 1, 2, 3, 4, 1, 2, 3, 4, tetravalency is maintained. So we want to name this. The chlorine is here, so this become our 1 because the double, this is an 18. So this become 1 chloroethene. 1 chloroethene. 1 chloroethene. So this is how the principle goes on and on. And we are going to have a whole lot of formulas, but the basic thing is our ability to be able to name them. So I've given us the rules, which you have seen so far. You use the rules and you name them. Provided you remember the rules, you will know what to do. So let us take some questions on how to name certain compounds. Let's see how that works. They say we should give the IUPAC name of the following. So let me write the structure so that we give the IUPAC name. So now we are naming section. After this, we'll have more that I want to deal with. So let's take them. C. Okay. Alright, that is it. We have been asked to name this. If you look here, 1, 2, 3. 1, 2, 3. The triple bond is at both ends is in carbon 3. Alright? But we have a chlorine in 2. And we have a methyl in 2. So where do we take precedence? Alphabetically, C comes before N. Chloro comes before methyl. Alright? So this will give precedence to this side. So therefore, I have my 1, 2, 3, 4, 5, and 6. The parent chain is 6 hexane. Alright? So now let's name it. I have chlorine in 2, so I have 2 chloro, 5 methyl, 3 hexane, or has 3 ion. I don't know which one you guys like. 3 hexane, or 5 methyl has 3 ion. Let's use this one. So this is it. They are asking us to name. Why do they want you to name this compound? Because it can be confusing. Some of you may decide to start here as 1 and call this 2. But this gives precedence to this. Alphabetically, we have our Cl coming before the methyl. So that is why we have to start from this other direction. Let's take another structure. You have any question when I'm done, you ask. Okay, let's see. Now I have to open it, expatiate in the whole stuff. So let's go. They say that there are 3 methyl group attached to this carbon. So this is my carbon. This is the carbon. Let me put my 3 methyl group. One of it is here, CH3, 1, CH3, 2, CH3, 3. This is what they say. That there are 3 methyl groups attached to this carbon. And after that, there is another carbon with a triple bond. Now, to this other carbon here, to this carbon, they say that there are 3 methyl groups again. So I have another CH3, CH3, and CH3. Now they want us to name the compound. 1, 2, 3. 1, 2, 3. So the triple bond is in between. The parent chain is 1, 2, 3, 4, 5, 6. Officially is what hexane. Now, if you call this at both ends, it is the same. So let me just take this to be my 1, 2, 3, 4, 5, and 6. Okay, that is true. From here, it can give me 2 years too. So let me take here. In carbon 2, I have 2 methyls. In carbon 5, I have 2 methyls. So this becomes 2, 2, 5, 5, tetramethyl. There are 1, 2, 3, 4. Tetramethyl has 3 ions because the triple bond is in 3. Now let's write it out. 2, 2, 5, 5, tetramethyl 3 hexane, or has 3 ion. Anyone you want there? Is that you call it 3 hexane or has 3 ion when you get to that position. So it is tetramethyl because we have 4 methyl. 1, 2, 3, 4. So take note of that. It is very important. You can see structures like this and you'll be required to name them, and you should do justice in naming them outrightly. Let's take, okay, that question was, we should give the IUPAC names of that. So we have done that. Now they give the structure of the following compounds. They say we should write the structure of this compound. So let us take the compound, and so we'll be able to bring out their structures. let's take our A. The parent chain is 5 pentyne. So let me write 5 first. They say 2 pentyne. So I have my 1, 2, 3, 4, 5. 2 pentyne. Carbon 1, carbon 2. So this is where my triple bond is. So that is my parent chain first. Now, this is the direction I'm coming from. Now they say 1 bromo. I have bromine here. 4,4 dimethyl. 1, 2, 3, 4. 4,4 dimethyl. Here I have CH3. CH3. Dimethyl 2 pentyne. So that's it. So now if I want to put all my hydrogens, I have this. 1, 2, 3, 4. 1, 2, 3, 4. Good. Come here. Hydrogen, hydrogen, and hydrogen. So this is it. 1 bromo. 4, 4. This is 1, 2, 3, 4, 5. 4, 4 dimethyl 2 pentyne. About 2 pentyne. So that's it for that A. Let's see B. There is still hexane, but we are having 2 4 here, 2 4 here, and we have triple bond. Let's see how that is possible. Now hexane is 6 and it's 3 ion, so it's in the middle. 1, 2, 3, 4, 5, 6. And they say it has 3 ion. 1, 2, 3. So let me put it here. This is what they want us to do. Let us put the stuff they want. 2, 4 dichloro. I want to start from here. So if this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So this is 2. They say 2, 4 dichloro. The first chlorine comes in 2. 1, 2, 3, 4. The second one comes in 4. So I think that is where the mistake is. Something is wrong. If this is 3 ion, which means it's in the middle, and they are asking you to put chlorine here in 4, means 1, 2, 3, 4, 5. This is not, the tetravalency does not exist. So as such, the question is incorrect. So that is how you can take note of that. So if I give you this structure and ask you to name, if you do not know, you go on putting your stuff inside and I will still fail you. But remember, the triple bond must be, all carbon atoms must have what? 4 bonds associated to them. So that is just the solution. They know that before they ask. Let us take another question. They say we should write the structures of 2 isomers of pentyne and give their names. So pentyne is an isomer. We should write the structures of 2 isomers of pentyne and give their names. So let us come down here. 2 pentyne. So the structural isomer of at least 2 of these. Alright? So this is 1. The next one, 1, 2, 3, 4, 5. I put the, pentyne is triple bond, sorry. This is 2 pentyne. I can put my pentyne here. This is 1 isomer. This becomes 1 pentyne or normal pentyne. And I can still have, this is 1, 1, 2, 3, 4. I can still have this 1, 2, 3, 4, triple bond. Yeah, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. The other substituent is here. CH3. 1, 2, 3 methyl butane. So I have pentyne as the name. If I like, I'll call it pentyne directly. Here is 1, 2, 3. 3 methyl 1, 2, 3, 4 butane, because the triple bond is in 1, or but 1 ion, but we don't need to call it but 1. So that is the question. They say give us 2 isomers from what? 2 pentyne and give their names, which are these. So let's look again. This compound, the type of hybridization in the compound above is what? Let's see. This is the compound they are giving to us. What kind of hybridization that exists here? We have the sp, we have the sp3, we have the sp2 hybridization. Alright? So we'll be able to know which one is the hybridization. So this is your assignment in case you've forgotten about hybridization. Tell us whether it is sp2 or sp3. It's a common question. That is a jam question. It comes out all the time and send your answer to the comment section. I'll see that. Let's take tougher questions. Okay, that is where we are. Let us take one more question on this before we close for the day. They say, what volume? Okay, how many grams of bromine will saturate? Let me write it. Now, this is the question. How many grams of bromine will saturate 5.2 grams of but1 in 3iron? What is saturate? What is saturation? To saturate a compound means you should make a double or triple bond becomes what? A single bond. That's why we have saturated hydrocarbons, which are the alkanes, single bond. We have the unsaturated hydrocarbons, which are the alkenes and the what? Alkynes. And they are asking us how many grams of bromine will saturate this compound. Now, we have to remember in the bromination or chlorination is the reaction of chlorine, bromine, iodine, or whatever it is, the halogenation with what? The given what? Unsaturated hydrocarbons for them to become saturated. So we will find out how many of those will take place here. And the question doesn't end there. This is under mole concept. So we have to apply the mole concept to know the number of grams that will do the chemistry. So let's start. Let's write but1 in 3iron. 1, 2, 3, 4. 1 in 3iron. Okay, so from here 1, 2, 3, 4. That is for butane. So this is 1 in 3iron. I have that already. Now, for me to replace this, I must bring 2 bromine. Okay? So if I want to bring this out, let me put it this way. I want to remove this. I'll bring 1 bromine, 2 bromine. It will give me bromine here and bromine here. And this to triple bond. This is my triple bond. To remove this, I bring another 2 bromine, Abi. And to remove another second one, I bring another 2 bromine to have a single bond. I want to saturate it. So I need 4 bromine to remove these 2 stuff here. So I put my single bond, 1 bromine, 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 and this is my hydrogen. So this compound is now saturated. Why is it saturated? It has what? All single bonds, no double bond again in it. So I put my hydrogen around it. So this is the compound. Now, what is the name of this compound? 1, 1, 2, 2. This is tetrabromo. 1, 1, 2, 2, 3, 4 hexabromo. Now, in carbon 1, I have 2 bromine, so I call it 1, 1. 2, 2. Now it would have been tetrabromo, but that's not the end. 1, 1, 2, 2, then 3, 4 hexabromo butane. So now I want to do this reaction, but let me bring out the molecular formula of this so I'll be able to calculate what the relative molecular mass of that. So let me bring it out. I have 1, 2, 3, 4 C4 H. Yes, I have how many hydrogen? 1, 2, 3. 4. Is it 4? Yes, sir. H what? 4. Okay, yeah, good. 1, 2, 3, 4. H4 Br what? 6. This is what I have. Now, this are the amount of bromine that will saturate this gap. In each double bond, in each bond, 2 bromine, another one, 2 bromine, another one, 2 bromine, 6 bromine. So if this is what I have, permit me to clean this so that we can do that reaction very well. Alright? Can I go on? Now, this is it. I want to take out this one. They say again, how many grams of bromine will saturate 5.2 grams of good 1 in 3 iron? So now I have 1, 2, 3, 4. Alright? I have C4H1, 2, 1, 2, 3, 3, 4, 5, 5. 1, 2, 3, 4, 5. So I have C4H5 for put 1 in 3 iron. That is what you get. Alright? Now if you look here very well, you see 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4 for this. 1, 2, 3. Oh, sorry. 4. So 1 hydrogen will go to the 4. C4H4. 1, 2, 3, 4. C4H. 1, 2, 3, 4. H4. So this one here you're seeing is put 1 in 3 iron. Now let me bring my mole concept inside. So this is it. I have C4H4 plus 3Br3. Br2, 6 will give me C4H4Br6. This is the number of bromine that will react with good 1 in to give us this. Now, equation of reaction. Let us now solve. They say how many grams of bromine will saturate 5.2 grams of this. So here, this. The relative molecular mass, let's calculate the relative molecular mass of this. Carbon is what? 12. 12 times 4 plus 4. What do we get? Here. 12 times 4, calculator. 48. Plus 4, what? 52. So 52 of these grams plus this. Let me take, okay, let's say, okay, how many of these? Okay, now 52 grams of this will give me, bromine is what? 80. 80 times 6. 480. 480. 480 grams. Now this is the status quo of the relative molecular mass of this. 52 grams of this gives me 480 grams of this. Then 5.2 grams of this will give me what? 5.2 grams will give me X. X is unknown. So if I want to make my X the subject, I will have, this is, come over here. I will now have this. X is equals to 5.2 times 480 divided by 52. And that is equals to what? 48. You've done that? 5.2 times 480 divided by 52. 48. We're good. So that gives us 48 grams. So that is what they are asking us. Have all of you checked that? Yes, sir. We're correct. Okay, 48.2. 48. Okay, I don't know what the calculator says. So that is your answer. So the answers here, they say A, 64 gram, B, 48 gram, C, 32 gram, and D, 16 gram. So you know the answer is what? 48 grams. So those which we have there, we have talked about the rules in naming the alkanes, which I said earlier on, the alkenes and alkynes are the same, almost the same. And we also talked about the reactions there in combustion reaction, additional reaction, hydrogenation, halogenations, hydrohalogenations, and the structural naming of all sort of compounds we're going to encounter. All right, we have dealt with that.